Alright kids, the first part of the second chapter is dealing with finding symmetry. You can't make fun of the hat. It is Farmer Day today, so no laughing at me. Anyways, we're going to find symmetry. What symmetry is if a graph can fold in half on top of itself, then it has some type of symmetry. Or if you rotate the graph and you still get the same thing, it has some type of symmetry. So, x-axis symmetry can be found if a graph is a reflection over the x-axis. Get it? X-axis symmetry. So if we have a graph and it can fold over the x-axis and land on top of itself, then it's x-axis symmetry. For example, a sideways parabola. The way you find it algebraically is a little bit more difficult. For x-axis symmetry, what you have to do is plug in negative y and simplify the expression, and if it's the exact same as the original equation, then it has x-axis symmetry. For y-axis symmetry, if we have a graph, it obviously is going to fold over the y-axis. So if you have a upward shaping parabola, algebraically, you plug in negative x to find out y-axis symmetry, and you simplify and solve. If you get the same equation out that you started out with, then it is x-axis or y-axis symmetric. For origin symmetry, the way you can tell if it is by the picture is if you can rotate the graph 180 degrees and get the same thing, then it is x-axis symmetric, or origin symmetric, So rotate it 100 degrees, people are like, what? Basically, if you take your book or your paper and turn it upside down, that is rotating it 180 degrees. And if the picture is the exact same shape, same design, same angle, same way it's pointing, then it will be origin symmetric. To find out algebraically if it is symmetric to the origin, you have to plug in negative x and negative y and test and simplify and see if you get the original equation out. So let's try some examples. Let's start with looking at some graphs. So if we look at these graphs, we're going to find the intercepts and we're going to state if it has symmetry. So the intercepts, let's go through that first. If you look at this first example, write down what you think the intercepts are. You should get 1, 0, yes, I wrote it as an ordered pair, and negative 1, 0. That's right here and right here. So, let's look at the next example. These are pi's, by the way, pi and negative pi. So this intercept would be pi over 2 and 0. This intercept would be negative pi over 2 and 0. And this intercept would be 0, 1. So that one had 3 intercepts, while that one only had 2. All right, if we look at this last example, this one is negative 2, 0. Our middle one is 0, 0. And our last one is 2, 0. So what we're going to do is we're going to determine what kind of symmetry it has. So let's check each of them for x-axis symmetry. X-axis symmetry, here is our x-axis. So if we fold our graph like a hamburger, so if you fold your paper like a hamburger, would the red lines be on top of each other? This red line would fold and land on here. This red line would fold and land on here. So this one is x-axis symmetric. If we check this one for x-axis symmetry, so we're folding it like a hamburger, that means this part would come down, and that would be down here. That doesn't match up with any red line. So this one is not x-axis symmetric. Sad face. Okay? This one, fold it like a hamburger, and it is also not x-axis. So let's go and test them for y-axis. So for y-axis, you fold them like the hot dog. So we fold these Bam! They meet on top of each other. Yay! This one, fold them on top of each other. Yay! This one, fold them on the top of each other. Sad face. Okay, now here's how you do it for origin. Pick this up and flip it upside down. If we pick this up and flip it upside down, is it the exact same shape with the exact same direction? And the answer is yes. So this is origin. If we take this one and flip it upside down, that means it would be a parabola facing upward, kind of. So it is not origin. Sad face. Doesn't have the same shape. Take this one, flip it upside down, and yes, it is origin. That is how you tell graphically what type of symmetry it has. So, finish the graph so that it has the kind of symmetry indicated. So this one is the y-axis. So here's our y-axis. We have this blue line here. If we fold it on the y-axis, so this side comes over here, our graph would be this pretty red line. For origin, if we turn this upside down, that's going to end up over here. And there is our origin symmetry. Yay, go you. Alright, so now, how do we find it algebraically? So this also wants us to find intercepts. We should know how to find x and y intercepts. To find an x-intercept, you put 0 in for y. So if I put 0 in for y, and I solve for x, what do you get? You get 0. So your x-intercept is 0, 0. For your y-intercept, you put in 0 in for x. So if we put 0 in for x, we have y equals 3 times 0. So you get 0. So your ordered pair is 0, 0. Yay, go you. Notice the same value. Okay? Symmetry. To test for x-axis symmetry, we plug in a negative y. If I try to simplify that, I might divide by -1. And when I do that, I get y equals -3x. Is that the same exact equation as the original? The answer is no. So it's not x-axis. For y-axis, you plug in -x. So I'm going to simplify this, and I get y equals -3x. Is that the exact same? No. So it's not y-axis. For origin, we are going to put in -y and -x. If I simplify, I get -y equals -3x. If I divide by -1, I get y equals 3x. Is that the same? Yes. So your answer is origin. Yay, go you. Alright, find the intercepts and test for symmetry again. So I'd see if you can find the intercepts in this one on your own. So we got x equals y squared minus 4. So for our x-intercept, we plug in 0 for y, and we get -4. So -4, 0 is our x-intercept. For your y-intercept, you plug in 0 for x. We have squared. You can do one of two things. You can factor or you can do quadratic formula. So I get 0 equals y minus 2 and y plus 2. The y minus 2 gets me the ordered pair of y equals 2, and y plus 2 gets me y equals -2. So that means 0, 2, and 0, -2 are your y-intercepts. Yay, go you. All right, from test for symmetry. So for x-axis, you might try this one on your own. X-axis, you plug in negative y. When you take a negative y and you square it, what does it become? You should say a positive y squared. Notice it's the exact same as our original, no simplification needed. So far we have x-axis. For y-axis, you put in negative x. So we have negative x equals y squared minus 4. To simplify, you might try and divide by a negative 1. When we divide by a negative 1, we get negative y squared plus 4. Is that the same? No. So not x-axis. For origin, you plug in negative x and negative y. So if we simplify the negative y squared, we get y squared minus 4. We can try what we did on the y-axis and divide by a negative, but we know it didn't work before, so it's not going to work now. So origin is out as well.